Hello, Hornets. In this video, we're going to be taking a look at the derivative of a to the x. We're going to look at how do we derive this, and just as we did before with the natural log of x, we're going to have to change it into terms of e to the x, or e to some power. Now, we know that the easiest way to do that is by changing it to y equals a to the x, so that we can exponentiate with the natural log. And according to our properties, the x moves in front. I'm going to exponentiate back, and I now have everything in terms of e that will make my life easier. Now, we are going to be utilizing the chain rule here, so please don't get too frustrated. Once we get the chain rule, we'll have to back substitute, and from that, everything should follow and flow nicely. So we're going to start with our dy dx and follow the chain rule. This is e to itself times the derivative of the inside piece. The derivative of that inside piece is the natural log of a, and the natural log of a times x, where the natural log of a is just a constant for a linear. We get that. Now, we already know that our x ln a, or ln a to the x, is the natural log of y. So I'm going to go ahead and I'm going to put that in. Now keep in mind that's going to give me e to the natural log of y, and that just leaves me with y. But we know that from the very beginning. dy dx must then equal a to the x natural log of a. And that's what we put right up here. A to the x natural log of a. Let's look at this again. I'm going to zoom out just a little bit so you can see it in its entirety. It would help if you can see it in its entirety. And there you go. So we start by letting y equals a to the x. We exponentiate. We clean it up. We exponentiate, but we do not simplify. That leaves us with e to a power. We then use the chain rule, e to the self, followed by the derivative and multiplied by the derivative of the inside piece. Let's take a look at how does log base a of x now work. Now keep in mind, log base a of x is going to end up following pretty much the same basic properties. So I'm going to start by letting y equal log base a of x. I'm going to exponentiate so that I get a to the y equals a to the log base a of x. And this allows me to have a to the y equals x. Now, I'm going to exponentiate again, this time getting it into a form for the natural log. Power moves in front. And now I can work with my derivative because the natural log of a is simply a constant. And I have dy dx. And this now equals 1 over x. There's only one thing left to do, and that's to move this natural log of a to the other side so that dy dx is equal to 1 over x natural log of a. And this is what we want to put right up here. 1 over x natural log of a. And that is the derivative for log base a of x. Thank you, Hornets. Be well, be safe, and I hope everything makes sense for you.